Hey guys, as always, I'm here with information you're not going to find anywhere else. So stay tuned, and I'm going to show you some things. We're working on the 12th year anniversary of Fukushima Daiichi. And what we see, what I got for you today, is a representation of what occurred in Unit 3. This is as long as I could find it, okay? But as you see, that fuel melted through the pressure vessel and landed in the bottom of the containment vessel. You see this water is burning off. Well, it's not just vanishing, it's building pressure inside the reactor. It's not just hydrogen gas either. There's noble and inert gases, there's tritium, there's all sorts of things in that gas. It created the explosion. The pressure originated in the reactor. And I can prove it. I've been proving it ever since. When this molten fuel hits that pad down there, what do you think since we've seen what it did to this pressure vessel metal, what do you think it's going to do to this concrete down here? We're going to take a look at some diagrams. I got some blueprints. And we're going to get a deeper understanding of where this fuel's at and what's happening in the reactors today and have been for 12 years. Focused upward shot. You can tell. Let's move over to some diagrams and pictures I have. This is an artist representation of the reactor and building. And as you see down here at the bottom, this is the ground. Everything from this line down is below ground. All this is below ground. This is below ground. Even the pedestal down here is below ground. This yellow line represents the operating floor line, and you can see this line on the outside of all the buildings there. They all have that same line, and that's the top of the actual hardened area of the reactor. All this is just sheet metal and some concrete, I guess, how they hold the metal on there. So here's the diagram. This is your ground level, right here. And all this is below ground. And if you look at the top here, you'll see piping going into the reactor. That would be your weak point of this Mark I reactor. Those pipes are what blew out the pressure from that gas building up pressure inside the reactor. It was focused upwards and had to come out to the side, which blew out some of the building. There's another diagram. Shows the fuel pool, pressure vessel, and then this is the containment vessel. Just to show you, changes in the amount of water transferred from the groundwater drains to reactor and turbine buildings, and in the amount of groundwater and rainwater flowing into the buildings. This graph is 2015 to 2018. And here you'll see this is when they started really making some progress with the ice wall, some progress. And you'll see that the levels come down. And before that, you see it, there's large sporadic up and down movements of water coming in and out. When it goes up, it comes in. When it goes down, the water is flowing out. Right here, this peak right here is August of 2016. And when I went to look what happened in August of 2016, Typhoon Mindil, August 2016 in Japan, affected Japan. So as the typhoon comes in, it increases the water levels, and as it goes out, it decreases. And we have another one here in 2017, around October. Of course, it's all the way over here. October 2017, typhoon land, Philippines, and impacts in Japan. So we know that the typhoons increases and decreases the amount of water from the groundwater to come inside the building, and then decreases as the typhoon moves out of the area. Okay, this is unit 3 from the top down from the crane. And on the left side, you'll have the service pool. And in the middle, you have your reactor. And on the right hand side is the spent fuel pool with the crane inside of it. Normal operations from here all the way across here to the service pool will be the same water level. When they change fuel, they do it through this little gate right here. They pull this gate and they can take fuel from here and put it in here. You'll see that the way the explosion blew out this corner, you can see where it originated from here out. And you'll notice here that this gap is much larger than this gap or any other gap around it. On this area is where the explosion originated from to push this wall and make that gap. You can see the clues right here in this picture. It originated from inside that reactor. This is the explosion. Now that we see the blueprints, see that fireball come out over to this side. That's where it blew out the side of the wall, and this is because the reactor is stood up on end like a cannon and shot it straight up into the air, which is different than Unit 1's explosion, which originated in the upper portion where hydrogen gas built up here, and then it blew off this top section. And you see the crane here. Well, that's what's laying in Unit 3's spent fuel. So this is Unit 2. This is the pressure vessel and the containment vessel. That explosion originated in here. If you think this whole area is still intact, I got news for you. It's not. Highest ever readings underneath Unit 2. And this isn't even the highest one. This is just the highest one they did when they made this graph. It's much higher. So that's what I got for you today, guys. I got the blueprint showing you. All this is underground. The melt is here, obviously. And there's no way that it stayed here on this pedestal in the concrete. It's had to leak down in here and even further below ground. And it is leaking out into the environment. 300 tons per day, because this is all filled up with water. We're trying to keep it cool. 12 years of this. And this is why Fukushima is worse than Chernobyl. Absolutely. This containment vessel is why they say Chernobyl was worse. Because Chernobyl released more in the explosion than Fukushima, with its one hydrogen gas explosion and one meltdown. They say that Chernobyl is worse because it released more in its initial explosion. We have 3 units in Fukushima, tons of material. And it is not being contained. Alright guys, tell me what you think down below. And thank you for watching. Until next time. Bye.